Welcome back to geometry. We are finished with quarter 3. This is the start of quarter 4. One quarter down, our last quarter to go, and it'll be summer before we know it. We're going to start off with 7.1 ratios and proportions. For a ratio, we have a comparison of two numbers. Please also show that this can be shown as a fraction, so A over B is a ratio. Or we could show it as A dot dot B. Or I can show it as A and then actually write out 2B. Okay, so all three of these things mean the same exact thing. There are three ways that we can show fractions, which are in turn ratios. A proportion is going to mean that two ratios are congruent. And what this is actually leading to is this cross property, or this cross product property. Now this is just a fancy way of saying cross multiply. Okay, and so you or we have done that time and time again in algebra 1, 2, in pre-algebra. And so if you were shown two ratios like on problem 1, this actually forms a proportion. We're saying that these two fractions are equal, which means they're each congruent, which means that these two ratios are now a proportion because we have an equal sign. So when we cross multiply, we get A times D, that's going to be AD, and we cross multiply the other way, we get B times C is just BC. And so we can fill that out down below. Well, when we do that here on the second problem, we get 5A equals 4B. Okay, and so how do we get that? Well, again, we just cross multiply. Now, they want us to turn this into B over A. So how do I do that? Well, let's think about it. We want B on top and A on bottom. So let's first divide both sides by A. We now have 5 is equal to 4B all over A. And if we can move this 4 out of the way, then we will do what they asked us to do. So how do we move this 4 out of the way? Well, let's divide both sides by 4. And so these 4's cross out. And so what I'm left with is I end up getting 5 over 4 is equal to B over A, which is what I was asked for. So for B, we're going to put 5. And for A, we're going to put 4. All right, one thing that you can note here is if you look and see A is on top, you see that 4 is also on top, and now it's been moved to the bottom. We have A and 4, and then B is with 5, and B is still with 5. Let's cross multiply going the other way. 8A is equal to 3B. And again, they want us to transform this equation so that it becomes A over B. So let's do this. Let's divide both sides by 8. And so now I have A is equal to 3B over 8. And let's divide both sides by B. And these B's cross out. And I have A over B is equal to 3 over 8. And so A is going to be 3 and B is going to be 8. And as we see up here, A is with 3 and B is with 8. And that's what we are showing down below. Next, we're going to cross multiply. We get 5A is equal to 4B. And if we want to transform this to A plus B all over B, let's use a shortcut. We see that A is with 4 because they're both on top. So I'm going to substitute 4 in for A, and then B is with 5. So I have 4 plus 5 on top, and B is 5 on bottom. So we end up getting 4 plus 5 over 5. And if we wanted to simplify that, we could get 9/5. Alright, more algebra review. We're going to cross multiply. 3x equals 63, x equals 21. This problem is not so easy to solve. We get x plus 8 times x minus 9. That's setting up a FOIL, and then 4 times 15. So when we FOIL, we get x squared minus 9x plus 8x minus 72 equals 60. We combine like terms, x squared minus x minus 60 on both sides minus 132 is equal to 0. And so we think about what multiplies to negative 132 adds up to negative 1. That would be negative 12 and positive 11. So x minus 12 times x plus 11 is equal to 0. X equals 12. X equals negative 11. All right, next part we have 3 times x plus 3 is equal to 4 times 2. 3x plus 9 equals 8. 3x equals negative 1. Divide both sides by 3. We get x equals negative 1/3. All right, then over here we get 2x times x plus 1 equals x plus 5 multiplied by 2x minus 3. And that gives me 2x squared plus 2x. And FOIL again, 2x squared minus 3x plus 10x minus 15. So that gives me 2x squared plus 2x equals 2x squared plus 7x minus 15. What's nice about this problem is these 2x squareds cross out. Minus 7x on each side. And let's take this problem up here. We get negative 5x equals negative 15. Divided by negative 5, x is equal to 3. All right, next problem. We have a scale model, and we're told that the scale model of a car is 4 inches long. So one thing we need to know is that when we put 2 marks, this means inches, okay? And when we put 1 mark, that means feet. Well, the problem with this ratio is your units aren't the same, right? It's like you're saying you have 4 apples and then you divide it by 15 bananas, okay? And we can't divide these numbers because these units aren't the same. So we have to make these units the same. Well, you have 2 choices. Here is option A. We keep 4 inches the same, and you convert 15 feet to inches by multiplying it by 12 inches per 1 foot. And you would get 100, let's do some quick math here. 15 times 12. I should know that. I should do that in my head. That's going to give us 180. Thank you very much. So we have 180 inches. We reduce 4 over 180. We get 1 over 45. Okay, and that was the easy option. Here's the more challenging option. We convert 4 inches. So again, it's the same problem, right? We have 4 inches over 15 feet. Okay, this time, let's create inches into feet. So 4 inches is 1/3 of a foot all over 15. Now, this still works. You get 1/3 divided by 15 over 1. Flip the second fraction, and we get 1/3 times 1 over 15, and we get 1 over 45. Okay, so you see that no matter which way we do it, we still get the same answer. But just know that in option 1 was much easier than option 2. All right, next problem, we have a photo that is 8 inches wide. So 8 inches by 5 1/3 inches. And we're told that it's going to be enlarged. So it's going to equal a new shape that's going to be 2 feet wide. And so if we look on top, I said that we had 8 inches wide. So I'm going to put W for width, and then I'm going to put H for height. And so we want to keep this the same. So this is going to be 2 feet width, and then X feet height is unknown. Okay, and I'm showing you width and height to make sure that these are lined up properly. All right, so just like last problem, let's choose option 1. I think it's much easier. So we end up getting 8 over 5 1/3 equals, we have to convert 2 feet into inches. So 2 feet times 12 inches would give me 24 inches. And so this becomes 24 over x. We cross multiply, we get 8x. 24 times 5 1/3 is 128. And then divide by 8. and x is going to give us 16 inches. And so that would be the height of the new poster. All right, moving down below with similarity. You can recall that from previous units. If we had, let's say that you were told that triangle cat is congruent equal to triangle dog. Okay? And when we looked at this sign that's called congruence, you have a similar sign and then an equal sign. Okay? And so when something is similar and equal, it turns into congruent. Well, today we're just going to learn about similarity, which is this sign. So we'll be looking at two objects that aren't congruent, that aren't equal, but they are similar. And so the one problem that reminds me of this is when we look at triangle cat and triangle dog. So let's call this CAT. And let's say that inside a triangle cat, you were told that we have 60 degrees, 60 degrees, and 60 degrees. Okay, and then you looked at triangle dog, and you could tell that it was much smaller than triangle cat. However, when you looked inside at each angle, you noticed that all the angles were the same. We had 60 degrees, 60 degrees, 60 degrees. They're both equally angular triangles. Well, these two shapes aren't congruent because clearly cat is bigger than dog, but they are similar because they have the same angle measures inside each angle for their triangle. So if you were told that all these sides were 5, 5, and 5, and let's say you were told that all these sides were 3, 3, and 3. Okay, so again, these two shapes aren't congruent, but they are similar. One thing that you can note here, which we're a little bit ahead of ourselves, but if you were to define the scale factor here, you see that you have a side length of 5 with cat and a side length of 3 with dog. Okay, and I'm getting in front of myself, but you can say that the scale factor of these two triangles would be 5/3. All right, 5 over 3. All right, similarity has same shape, but not necessarily same size. So if we think about triangle cat and triangle dog, we have congruent angles, and we have similar, or let's say this better, proportional sides. So here we have triangle ABC is similar. It's not congruent, it's similar. Well, angle A is going to be congruent equal to angle D. Why is that? Well, if two shapes are similar, all their angles are always congruent. So we know that measure of angle A is going to equal the measure of angle D. Measure of angle B is going to be equal to the measure of angle E. And measure of angle C is going to equal the measure of angle F. Furthermore, if I went AB, 1, 2, I would have to go DE. If I went BC, right, if I go BC, then I'm going to second, or 2 to 3, so 2 to 3, that would be EF. And then AC, first last would be DF. All right, we're back. Let's take a look at this shape. We're told that the two shapes are similar. So one thing we know is that all angles are congruent in similar shapes. So we can move the 160 down here. We can move 100 down here. Now, one thing that was left off this drawing, the K shouldn't be there. So let's get rid of the K. And then these two lines should have been told you that they are parallel. So we're going to put arrows, 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 and arrows. Now we can solve the problem. So measure of A prime, or smaller shape A, is going to be 100 degrees. Measure of angle C is going to be 160 degrees. So next we're asked to find B. Well, if two lines are parallel cut by one transversal, Then these are same side interior, so this becomes 150 degrees. So I can put 150 here, and I can put 30 degrees here. Furthermore, since this is a pentagon 5 sides, we know that we have 5 minus 2 times 180 degrees, which gives us 540 degrees. We add up all these angles. We see that angle B would have to be 100 degrees. All right, the angles. These are easy, okay, because we know that the angles will always be the same in both shapes that are similar. What's not easy is finding the sides. Okay, so this is more challenging. This is where we have to be really careful about our work. We're asked to find x first. Let's highlight this side, and I'm going to highlight the same side in our small shape. So I'm going to start off with x over 2. Okay, then let's highlight 6, and maybe let's change colors. Let's go to yellow, and we're going to highlight this side, which is 6, and highlight this side, which is 4, so we have 6 over 4. All right, and so now what I can do is I can cross multiply, and that gives me 4x is equal to 12, x is equal to 3. We can do the same for y. Let's change colors again. Let's highlight y. So here's y side, and I see that it corresponds with 9 on the bigger shape, so y over 9 equals. And since I'm going from small to big on this problem, I still have to go from small to big. And you can use any side that you want. I'm going to use 4 and 6. So y over 9 is equal to 4 over 6. 6y equals 36. Y is equal to 6. All right, and then for z, let's change colors once again. Z is our base, so we're going to stay with base to base. So we have z over 8, and it's going to equal, what do we want to use? I guess let's go 9, or excuse me, sure, let's go 9 and 6. And so I went z, so small, so this would have to be, I'm going to use the 6. And you can't see it, but 6 is right here. We found out that this length was 6. And then over 9. So 9z is equal to 48. And when I reduce that down, I'm going to get, let's divide by 9, z equals 16 thirds. Alright, next problem. Alright, I think it's always smart to redraw the smaller shape, and so we can get an idea about what's really going on here. And so here's x, here's y, here's z, and here's 8. And here's our 90-degree angle. Alright, and let's start off. We're asked to find x first. So highlight the x side, and then that's going to be this entire side, which is going to be 12. So I'm going to start off with x over 12. Now, I'm going from small to big, so we have to keep that in order. Next, I'm going to use 8, and then when I use 8, it has to be this entire base, which is going to be 8 plus 16, which gives me 24. So this entire base is 24. So I have 8 over 24. Next, I'm going to reduce this fraction first. So x over 12 equals 1/3. And how did I get 1/3? Well, 8 over 24 would reduce to 1/3. That gives me 3x is equal to 12, x equals 4. Alright, next let's change colors. We're asked to find y. Let's do y next. I'm going to highlight the two tops. So I have y over 18 equals. And I guess let's use, we'll use 8 and 24. So 8 over 24. So y over 18 equals 8 over 24 would reduce to 1/3. 3y equals 18. Y is equal to 6. Alright, and then one more to go. Z. So we highlight z in 10. And so I can say z over 10 is equal to, and this time, again, we can use anything we want. I guess let's use 18 and 8 again. Or sorry, let's use 8 and 24 again. There we go. So 8 over 24. So z over 10 equals 1/3. 3z is equal to 10. So z equals 3 and 1/3. All right, next shape. We see one small triangle, we see a huge triangle, and a trapezoid. So again, let's redraw the shapes. There's 12, there's 16, there's 24. And we're going to redraw the other shape as well. And so there's, oh, excuse me, this is not 24. Let's hard erase that. This is going to be 12, 16, and x. Silly me. So we'll put the x here. There we go. And then 12 plus 9 is 21. 16 plus y is 16 plus y. And then we have 24 on bottom. We're going to hit pause because I had some students that just walked in the door. I'll be right back. All right, my students just left, so let's get back to work here. We're trying to solve x. So again, I always like to highlight what I'm trying to solve. So I'm going to highlight the base. And I see that I'm going to then compare this to this base. Now, one thing that I did that's a little misleading is you have a negative sign there. Let's get rid of that. All right, much better. So I'm going to start off. I have x over 24. And then we're going to take 12 and 21. And I had another student that just walked in, so I'm going to pause this and I'll be right back. All right, I apologize again. I'm back. So we have x over 24 equals 12 over 21 would reduce. If we divide by 3, we get 4/7. So now we have 7x equals 96, and then we get x equals 96 over 7, which ends up coming 13 and 5/7, I believe. All right, next let's change the color. We want to solve for y, so we have 16 plus y on one side, 16 on the other. So 16 plus y over 16 equals, and let's stay with 21 and 12. All right, 21 and 12. So the thing that you have to watch out for is if you go big to small, you have to go big to small on both fractions. So that's exactly what I did. I have 16 plus y, so big to small, and then 21 over 12, which is big to small. When we cross multiply, first let's reduce. So 16 plus y over 16 equals 7/3. We get 3y plus 48 is going to equal 17 times 6 is going to give us 112 minus 48 on each side. We get 3y equals, actually I made a mistake, this is 7/4, excuse me, 7/4, so that's going to be 64 minus 64 on each side, and we get 48, and so y is equal to 16. All right, next question is somewhat of a trick question. Is triangle MUN similar to triangle day? And these triangles actually are, because all of their angles are the same. We have 3, 3, 1, 1, and 2, 2. All of these angles are the same. Therefore, yes, they have to be similar. Now, if you didn't see that trick, let's compare all of the sides. And we have 12 is to 16, as 15 is to 20, as 18 is to 24. When I reduce all of these three fractions, I end up getting 3/4 equals 3/4 equals 3/4. So if we didn't know these angles, let's say that these angles weren't shown to us, well, then we can look at the sides. And since the sides have the same ratio, then we can say that these two shapes are similar. Thanks for joining us. See you next time.